Okay, so if we were going to use this unit circle to find the sine of an angle, please stop talking. What would you do? That would be the y. And if you want to do the cosine? S. Okay, so let's go. In the last class I said we're going to put something else on the unit circle. That's not true. We're going to put something else on this paper. There is nothing else to put on the unit circle. But I want to draw a little sine graph. So we're going to do a parent function of sine, and we're going to do a parent function of cosine on here too. So you're going to have a whole lot of information on this sheet. So how long does it take for the sine to do its whole period? 2 pi. Yep. So we'll put a little mark at 2 pi, a little halfway at pi, and then we'll do 2 more little quarter marks. For the parent function sine, the amplitude's 1. And then sine always starts at a middle, up to a max, middle, min, middle. I'm not going to say always. The positive sign will do that. All right, so that's the basic shape of sine. All right, we're going to do another one of these guys for cosine. And then where does cosine start? Like at 0 if there's no shifting? A max, yeah. So it looks like the Texas Longhorn shape. All right. So we are going to use this unit circle, and we're going to do a graph of the parent function of tangent. Now, I think it was Stacy the other day asked me, like, what about the tangent graph? And I was like, hold off, we're not ready for that yet. Well, today's the day. We're going to learn about the tangent graph. And so one thing that we're going to try to remember from before when we talked about tangent, we just talked about tangent a tiny bit, is that the tangent of an angle is equal to the slope at that angle. So we can find tangent on the unit circle actually 3 different ways. So using the slopes is one way. And I kind of like that way actually. Okay, so I'm gonna draw a little X and Y axis for tangent. All right, and I am gonna start at 0 when everybody's ready. We'll give you guys a little bit of time. Okay, so if we're just going to think about tangent as the slope at that angle, at 0, here's the angle. What's the slope of the horizontal line? 0. So we're going to start at 0. All right, and then as we go around this circle, would you say these slopes are positive or negative? Positive. So it starts off kind of small. Starts off at 0, and then it's kind of small, and then it increases, and then like when you're like up here, it's a super steep, and it just gets steeper and steeper and steeper. So it's like approaching a slope of infinity, and then we get to this vertical line. What is the slope of a vertical line? Not 0.
1.
Not 1. 1 would be right here. This is the slope of 1. Undefined. So the slope of a vertical line is undefined. So when we did graphs before, we were doing rational functions. There were two things that were undefined on the graph. Do you guys remember what they were? I can't hear.
The vertical asymptote?
Vertical asymptote, that's the one I was looking for. There's a hole. This graph doesn't have a hole. This graph has a vertical asymptote. And so where this graph is undefined, there would be a vertical asymptote. So where's one of those places? What angle would that happen at? Pi over 2. And a vertical asymptote is just drawn as a dashed vertical line the graph approaches but won't quite get there. All right, and then that takes us into the second quadrant. So as we go on the second quadrant, would you say these slopes are positive or negative? These are negative slopes. So it starts off super, super steep, almost at infinity. And then it starts getting less and less steep. Sorry, I need to charge my Apple Pencil. Okay. No. 0 and 2 pi are that angle. Sorry, that's not true. No rotation at all is 0, and a full rotation is 2 pi. So they have the same terminal lines, the terminal side of their angle. So no rotation is this angle right here, and then a full rotation ends up at the same place. They have the same tangent, they have the same sine and cosine. They're different angles because one hasn't rotated at all and one has rotated all the way around. Okay. All right, so we're getting less and less steep until we get to 0. What angle would have a slope of 0 on that side? Pi. Yeah, so that's where it's horizontal. So that's a slope of 0. All right, and then that takes us to the third quadrant. Just kidding, third quadrant. All right, are these slopes positive or negative? Positive. So it starts off kind of flat and gets steeper and steeper and steeper. Positive. Until we get to a vertical line, and that's going to have an undefined slope. So what angle is that going to be at? Yes, sir. Good. All right, so that is a period and a half of tangent. I haven't drawn it beautifully. If I continued this pattern, this is one period of tangent, this shape right here. I'm going to continue it on the negative side. So where should this vertical asymptote be? What angle? Negative pi over 2. Very good. All right. So we just did 2 periods of tangent. So vertical asymptote to vertical asymptote is a period with this shape in between them. So how long is the period of the parent function of tangent? This is 2 periods graph. Okay, you guys aren't getting it. This right here is the length of a period. This is the length of a period, this is the length of a period. It's just pi. Someone might have said that. I heard pi over 2 and I heard 2 pi.
Kenny said pi.
Good job, Kenny. So what was the period of sine? We already said that. We're just going to write it on here. The parent function of sine has a period of 2 pi. Cosine has a period of 2 pi. So tangent just has a shorter period, and that's fine. It doesn't matter. It's just one more thing you do need to remember. All right, so also on this unit circle page, we're going to write how you use the unit circle to find the tangent when everybody's ready. So do you guys know what to do with x and y to find the tangent? It's y divided by x, or it could possibly be y times the reciprocal of x. So most of these points on the unit circle are fractions, and so I would probably do that y times the reciprocal of x most of the time. Or if you wanted to, you could use the slope. So at the quadrants, that might be the easiest way to do it, is just look at the slope. Do we know the slope here? That's the slope of 1, because we already talked about that's halfway in between those two. What would this slope be? -1. So the pi over 4s are pretty easy to just use the slopes to do them. You also could do the sine of theta divided by the cosine of theta if you wanted for tangent. That one we probably use the least right now. We'll use that a lot later. But also if it's a triangle, there's another way to find tangent. Do you guys know the TOA part of SOHCAHTOA? Yeah. So some of you are done taking the ACT, I'm sorry. But the rest of you are going to take it at least probably 1 or 2 more times. And there are 4 trigonometry questions on the ACT. We don't do triangles in this class, but knowing SOHCAHTOA will help you probably get one of those questions right. Okay, so here we go. Let's look at Brian Passwater's notes. He went through everything I just did. I'm not going to reread it to you. I haven't given you this yet. Hold on. Okay, so he just reminded you about all the different ways you can find tangent at the top. And then he went through the angles, the slope of the angles like I did. And then about halfway through on the first page, he says that when pi over 2 is, when theta is pi over 2, the terminal ray is now vertical. And the slope of a vertical line is undefined. And then he went through some angles in quadrant 2, and then we got to quadrant 3, and then the pi over 2, we had another vertical line. So a key concept is that each time the terminal ray is vertical, the slopes are undefined because they're approaching infinity or negative infinity. When the graph of the tangent, when we graph the tangent function, what are we going to have there? What's going to be on the graph where the slopes are undefined? Vertical asymptote. Good. Very good. And then he has a really beautiful graph of tangent. So this is like almost 4 periods of tangent, the parent function. I like to say that tangent is a happy graph. Because it's increasing everywhere. It's going up, it's rising everywhere, except for where it's undefined. Do you think there's anything that could happen to make tangent a sad graph? Where it's always reflection on the x-axis. What part of this guy is going to make you have a reflection on the x-axis? A. So if A is negative, then this is sad graph. I really need to charge this for more than 2 seconds. Okay. All right, and then, yeah, it's kind of a similar table for a tangent that we did with sine and cosine. Normally, well, always, the absolute value of A for sine and cosine gives you the amplitude, which is the height between the midline and the maximum point. Is tangent going to have an amplitude? No, there is no maximum. It just keeps increasing and increasing. So if for some reason you're asked to find the amplitude of tangent, there is not one. There's an A value, but that doesn't mean there's an amplitude. Okay, so let's look at the rest of the properties. So that A does give you a vertical dilation. It could possibly give you a reflection. One thing that's very different is this right here. So the period for tangent is going to be the absolute value of pi divided by b. The horizontal or phase shift is going to be exactly the same as sine and cosine, and so is the vertical translation, or the midline will be the same. Okay, so let's look at some graphs. So on example 1, we have this graph of tangent, and we are told this is like the generic form. Is this one going to have a phase shift? No, because there is nothing added or subtracted inside, so we're just going to find A, B, and D. So let's find D first. What is D? Has this one been shifted up from the original graph? Yeah, so D is just going to be 0. So if in between your vertical asymptotes it's an x-intercept, then there is no vertical shift. All right, B we're going to find by using the period. So what is the period of this tangent function? We need this distance, pi over 2. So it's a pi over 4 to the right and a pi over 4 to the left. That you add those together to get pi over 2. You're technically subtracting pi over 4 minus negative pi over 4, but that is going to be the period. And then whenever we want to find B for tangent, we're going to take the period and we're going to set that equal to pi over B. So when I write it like that, this one is kind of obvious what B is going to be. So if pi over 2 is equal to pi over B, then what's B? Yeah. It's not always that obvious, but you're going to do it just like we did with sine. I'm not worried about finding B. You guys did it at least 4 times on your test yesterday. I think you're fine. Just remember for tangent to use pi instead of 2 pi. All right, finding A is a lot less straightforward. Finding A on sine and cosine were super easy. Tangent is not super easy. So one thing you can do is just find where the graph is equal to 1, and you're probably gonna have to approximate it. So what x value looks like gives you 1 for the function? I worded that really weird. Yeah, that's pi over 8. So we know, probably, that f of pi over 8 is 1. So what I can do is take this and put it in for f of x, or take 1, put it in for f of x. Take x over 8 and put it in for x. Sorry, take pi over 8 and put it in for x. Take 2 and put it in for b, and 0, put it in for d, and then solve that for a. So it should be 1 equals a, tangent of 2 times pi over 8 plus 0. You can forget about the plus 0 if you want to. All right, what do you get when you multiply 2 times pi over 8? Yes, sir. All right, now pi over 4 is my favorite angle to take the tangent of because I already know that it's going to be 1 because I know that that's the slope of 1. If you don't just know it, there's different things you can do. You can go through and you can take the y and divide it by the x. And what do you get when you divide something by itself? Just 1. So this ends up being a times 1, or a is just going to be 1. Okay, so finding a is a little more challenging than before. We are not going to have an FRQ where you actually have to find a. That will always be sine and cosine. That FRQ we did in our test yesterday will never be tangent, so don't worry about that. Okay, let's look at example 2. So it's a totally different function. This one's called h. H is 4 times the tangent of 2x plus 5. And we want to find the period. So just a reminder, the period of every tangent function is found by doing the absolute value of pi over b. What is b in this equation? 2. So the period should just be pi over 2. And then this next example where you find all of the asymptotes is a kind of a common question that you'll see on your assignment. So to do it, I just want to write some things down about the parent function asymptotes. All right, so these are the parent function asymptotes. One of them is at pi over 2. And then what is the distance between the asymptotes? Pi. And how is that relevant to the characteristics of tangents? It's the period, right? Okay. So let's just jot some of that down. Y equals tangent of theta has an asymptote at x equals pi over 2. And an asymptote is repeated every pi units. I worded that weird, but I think it's okay. All right, if your function has some kind of horizontal change, either a horizontal dilation or a phase shift, then that is going to move the asymptotes around. So this one definitely has that because of this 3. So we can apply that horizontal dilation to the original asymptote. And so what we'll do is take that x over 3 and set it equal to where the asymptote would be for the parent function, and then solve it for x. All right, so that is a new asymptote. And when you look at your answer choices, there's only one of those. So what do you, okay, and there's also a typo here. I fixed it on your homework, but I didn't fix it on this. So all of these where it says is a constant should be an integer. It can't be any constant. It has to be an integer. It can't be a fraction or a decimal. So where do you guys think this 3 pi is coming from? Okay. So here it's repeated every pi units because that is the period of the parent function. This one is going to be repeated every 3 pi units, probably because it's the period of this function. So let's make sure that's true. So the period, we're going to take pi and we're going to divide it by b. What is b here?
1/3.
Yes. So last class they said x over 3, and that's very close, but x is never in your period. So it's just 1 over 3, and then how do you divide by a third? Multiply by 3. So that is why that 3k is there. All right, are y'all okay? It's a lot of new information. All right, let's look at, this is pretty common. We have the graph, we're gonna match it up with its equation. So let's just start off with the easiest thing to find. Don't talk to her, she's taking a test. The easiest thing to find, which is the midline. So what's the midline of this one? -2, yes. So we can mark out choice B and D. All right, so it's all going to come down to the period. So the only difference between choice A and C is what the B value is. So what's the period of this function? I think someone said it. Say it louder. Yes. So we have a pi to the right and a pi to the left, add together to be 2 pi. All right, so I'm going to take that 2 pi and I'm going to set it equal to pi over b. So what's b going to be? Yes, ma'am. So what do you guys think the choice is? A. Nice job. Okay, and then example 5, I know this is a lot of problems, but we're actually going to do them really, really fast because we're just going to use our unit circle. All right, and so if you're looking at the unit circle and we want to find the tangent, and it's not an angle you just know the slope to, we're going to do either y divided by x or y times the reciprocal of x. If it is 1, we know the slope to, or we can just give the slopes. So if you look at pi over 6, is that a slope you already know? Probably not. All right, so what we're going to do is take the y coordinate and multiply it by the reciprocal of the x coordinate. What's going to happen to those 2's? You're going to cancel. All right. And probably in Algebra 1, we're taught not to leave that radical in the denominator. We don't care. Pre-calculus and calculus, radicals stay in the denominator. Nobody cares. Do you guys already know the tangent of pi over 4? Yeah. So you have options. You can do the slope if you want, or you can take square root of 2 and divide it by itself. All right, pi over 3, you probably can't do that using the slope, so we'll just take the y, multiply by the reciprocal of x. Twos cancel out again, and you get the square root of 3. Okay, so I want you guys to finish D through I for me, please. It's, no, you just flip the x. So it's y, and then flip the x. Yeah, flip the x. So, do you guys think there's a relationship between all the tangent of pi over 6's? Yeah. So they're going to be the same fraction, just sometimes positive, sometimes negative. So if the x and y have opposite signs, like in quadrant 2 and quadrant 3, it's going to be a negative. They have the same sign, like in quadrant 1 and quadrant 3. 2 and 4 have opposite, 1 and 3 have the same sign, then it'll be positive. All right, same thing for the pi over 4's. The pi over 4 tangents are either going to be 1 or negative 1. The pi over 3 tangents are either going to be positive square root of 3 or negative square root of 3, depending on the quadrant that you're in. All right, and then when you get to the quadrant angles, you can do the slopes, which is what I like to do, or you can do the x and the y. So if I did the x and y on G, it would be negative 1 divided by 0. Anytime 0 is in the denominator, it's undefined. What about 0 in the numerator? Is 0. And that's what happens on this one. All right, what questions do you guys have?